what Violet is doing at the micro scale, we're going to be doing at the macro scale. So just as the picture shows, you know, everyone knows Star Trek's tricorder, right? It measures everything. Believe it or not, we're on our way there to be able to detecting virtually anything that's in the environment right on a modular device. And my history is in aerospace engineering and a lot of years in optical metrology over the last 30 years. I have various patents in the area, and I had a company before that has sold in 2015. So today's typical process for identifying, you know, macro scale artifacts is basically you have to go to the crime scene, whether it's the grocery store with fruit that's not ripe, or whether it's at a real crime scene looking for cocaine or other toxins in some crime, you know, stricken area. But basically these processes are quite difficult, right? And it's all prone to human error. Basically you have to go to the site, you have to collect samples, you could contaminate it right there. You then bag it and then send it to your department. You can contaminate it right there. Then they ship it to a lab. It can be contaminated just on the trip there. The lab takes several weeks often to get the results, sending it back, again, contamination again there. And that contamination can go both ways. Depending on what the substance is, you can contaminate the environment, or vice versa, you can contaminate the substance. So this whole process takes often weeks to months and is completely prone to human error. So it's very outdated, and new technologies are coming around the corner to solve this on a more massive scale. So how do we do this? Does everyone realize that science is only discovering what nature already does? And spectroscopy, as we've known for all these years, has been in nature for all as time as we can remember. A raindrop is the most basic, simple spectrometer. Light goes through it, it spreads the light out, and we produce the rainbow. Crystals in your living room do the same thing. They produce a rainbow when the light travels through it. Turns out those two rainbows are completely unique. They're like fingerprints. And now we have cameras coming out where every pixel in the image has that unique fingerprint. As a result, we have data instead of just one image that you get from your phone. You have 2,000 images, each one taking a different wavelengths, producing this fingerprint. And I will be focusing on the software for my company, and there are quite a few companies now starting to make these cameras. The market is 48 billion TAM, 20 billion SAM, and we're hoping to reach 50 million by 2032. The market areas that you can see are spread across from forensics, agriculture, pharmaceutical, all the way across the board, and eventually mobile phones when these types of cameras come out soon. So the problem is, as I mentioned, way too slow and error prone and too many stages in the process. Solution is that we're going to do what Apple did with the iPad. Nope, the iPod. Too many P's in there. But basically, we are combining all the various stages into a single package. You have your mobile device, you have software that acquires the data, you have software that processes it, sends these fingerprints off to a database, which we're offering subscriptions for, and returns and comes back and tells you all the different types of substances that the objects are made of that are within that image. So currently we have products that are available on laptop. We have various cameras that we integrate our software with 6 different manufacturers at the moment, and we have our own scanners for very high precision lab type and field type experiments. Here's an example of the application where it's automatically identified various types of flora and in the image. So it's the product's pretty much ready. Market, forensics to start, agriculture, climate change. Put your camera towards a smokestack and you immediately know what toxins are coming out. And be ready for the mobile market when it comes out in a few years. Business model subscriptions for access to the databases, software licenses, and hardware sales. Go to market, trade shows, digital advertising, and distributors, which we have 3 of worldwide at the moment. 50 million, 5 by 2032. And competitors, we have 3. 2 of them have already been purchased by other larger companies, and none of them have the breadth that we provide in terms of power, subscriptions, and the amount of hardware that we can access. The team is myself at the moment, but we're also working with Catapult to have, mentors, and we have 2 investors, already. So at the moment, we have already accumulated $344,000 in angel investment, and we're now seeking $750K in a safe with $5 million cap, and going from there. Thank you.
So I should note there's also a CrowdStrike for pathogens sort of play here, because all these disparate databases that different research organizations have, you're going to be able to combine them into sort of central source for all these thumbprints, so to speak, and sell that out on a subscription basis too.
Right, because there's over like maybe 10 or 20 different databases that are all individually run by governments and institutions. And we're the only ones who access all those databases and be able to search them and give you instant results from all of them. And that's where the subscription comes in.
Questions for Raymond?
Thank you, Raymond. Can you talk more about your ideal customer, where you're starting with, and how you reach that target customer?
The 2 target markets, in the immediate term are forensics and art. Art is smaller but more accessible as far as the amount of work to get that customer. Where you're identifying, you scan an entire art piece, and you can identify all the different substances were used to create it, and also the age, and probably even where those substances came from across the different, across the planet. For forensics, we have police departments, we have crime labs, we have detective agencies, where they can actually perform those tests either on site or right in their office. And for those, we basically will pretty much give them a call, let them know what they have, walk in, get the interviews, and start the chain rolling from there.
Any other questions?
Raymond, really interesting technology, but I guess, in my view, right now you're a one-man band. There is no team. What are your thoughts about that? Do you have people in mind? How are you going to build a team?
Currently, we have 6 companies, hardware companies, that are using our software with their instrumentation. So we already have like an OEM team that are selling their instruments, and they'll be selling our software to go with them. As far as product development, we basically will go as the need goes to enhance the product. But basically, the core engine product is platform independent, and now we would just hire programmers to basically take the building blocks, like Lego sets that are in this SDK that we offer, to build customized applications for different markets. And Catapult, as we go through that, we're going to be basically, as far as finance management and day-to-day management, hire, as we go. So we're pretty much at the beginning stages there, but on the product development side, it's pretty much done. And we already have OEMs and distributors for the product as we speak.
But the answer to his question is going through Catapult.
Yeah,
we will be
going through
identifying
the process.
Fractional team members initially, some of whom may end up joining the company long term. But we know he's a one-man band, and we definitely need to augment. But that's part of what we do with just about every company.
Right.
Thank you, Raymond. Excellent.